Thank you all for joining. We're going to watch two quick videos from our sponsors, SSRCx and TLC Engineering Solutions, before we get started.
When SSRCx performs new construction commissioning and lead commissioning, their three-phase approach gets building systems operational and functioning to their full capacity. SSRCx also performs retro-commissioning by optimizing an occupied building systems to meet the occupants' and owners' needs. SSRCx is also just one of a few companies in the world licensed to provide continuous commissioning services. By optimizing HVAC system operations for existing conditions and providing ongoing monitoring of energy usage, continuous commissioning provides owners with the best performance at the best cost. SSRCx also provides building enclosure commissioning to look at moisture control, air leakage, and energy performance. SSRCx, Smith Seckman Reed's Commissioning Division.
Since 1955, TLC Engineering Solutions has been a trusted advisor to building owners across the Southeast and beyond. While we might be known for engineering high-performing buildings, our energy services teams have been commissioning, retro-commissioning, and performing energy audits and facility assessments on technically complex buildings for more than 20 years. But more importantly, we love what we do. So we think boldly, listen attentively, and create passionately to produce high-performing environments. That's TLC.
Hello, good morning, good afternoon, or evening, depending on what time zone you're joining us from, and welcome to the final session in the 2021 CxEnergy virtual webinar series. And special thanks to SSRCx and TLC Engineering Solutions for sponsoring this presentation. I'm going to address some important notes before we get started today. In order to receive a certificate of completion, you must be a registered attendee and use the personalized link that was sent to your email address to join this webinar, not a link that might have been shared with you. Once each live presentation finishes, you will receive an email with your certificate within 24 hours. Additionally, if you are a certified CXA, EMP, TBE, then staff will be uploading your certificates of attendance for you to your respective member portals, and this will be completed in a few weeks. All live webinars are being recorded, so if you happen to miss one, you'll be able to review it 1 week after the live event. During the session, we encourage you to submit questions at any time using the Q&A button. Chat function is where you can make general comments and chat with attendees. And if you happen to be experiencing technical issues, please use that same chat function to inform the panelists, and we will help you out. Today's webinar is Guideline 3rd Edition, Understanding Emergency Power System Commissioning. A few words on our speakers today before we get started. Jesse has been a senior commissioning authority with SSR since 2007 and is currently the Electrical Commissioning Discipline Manager. An electrical engineer, Jesse is also an active committee member with ACG's CX Guideline Revision Committee. And then Mark specializes in energy efficient facility design, sustainable design strategies, energy management, and commissioning. He serves on the board of directors for ACG, served on the EMA board until ending his term yesterday, and a past vice chair of the USGBC National Lead Implementation Advisory Committee. So I'm going to hand things off to Jesse to kick things off today. Jesse?
Mark, is that true? You ended your EMA yesterday?
That's right. The honor is to serve, but it's time to get some new blood in onto the EMA board.
Okay. Before we get started, I think you also did the speaking part for your intro. Very impressive.
I have a face that was meant for radio. Yes.
The downside of these remote presentations, Mark and I can't look out at everybody, but it is also more convenient in some ways. It seems to be about every year there's one or two of these presentations for emergency power, and Mark and I wanted to go into this with a more practical approach. We are members of the next ACG Guideline Committee. Traditionally, pretty mechanical heavy with sprinkling of electrical, and they maybe to their chagrin have invited Mark and I, electrically minded folks, to be part of the committee, and the result of that is what we feel is a much needed emphasis on emergency power equipment and systems commissioning. And the result of that effort is what we're presenting on today. The next guideline is going to include emergency power system commissioning. And Mark, correct me if I'm wrong, I think in the near future, CSE Magazine is also going to put out something along those lines.
That's right. Jesse and I took what was going to be in the guidelines and kind of tweaked it to make it an article, and it's going to be published soon. So look out for that.
All right. So we're going to try to keep this maybe a little bit of banter in this presentation. It could be dense, but we want it to be beneficial. At the end of it, we want folks to walk away with some practical knowledge, some firsthand accounts of how to commission an emergency power system, not just talking about what to look forward to in the guideline, which we're both extremely excited about. There's some good stuff. It's all good, but there's some particularly interesting things that we feel are new. The audience we have in mind isn't providers, and it shouldn't be. We're approaching this as if we're speaking to clients, engineer of record, AHJs, and my personal favorite, facility operations, the folks that don't always have a voice in the room, but should be heard loud and clear. So the first couple slides are AIA required for credit, and I want to reserve most of our time for getting into the weight of the topic. So I'm going to assume that you're here today. You had to read these things before you clicked and signed up to get an invite. So we're not going to spend too much time reading from slides. That may bite me in the butt, but I can almost guarantee Mark's going to do well. Learning objectives, we have these covered at the top of the slides. If there's any question, there should be clearly marked. This and then some more. So with that, Mark, I'm going to hand it off to you.
So if you've seen me present before, you've probably heard me say that with great emergency power comes great responsibility, which I believe is true, but it's also fun to quote, Spider-Man. And if you haven't figured out, Jesse and I both are, nerds, I guess is the right term, but we have a love for all things superhero and comic book, which you'll see throughout here. But I'm going to start by just giving us a little bit of an introduction and talk about some definitions and jargon, because there's a lot of jargon, there's a lot of terms and a lot of abbreviations and acronyms, and I always like to make sure that we're starting off on the same page, especially for you mechanical folks that might not know the electrical stuff. So we talk about generators and emergency power systems commissioning, and we say a lot of different things, but we mean the same thing: generator, genset, emergency generator, engine generator. What we're talking about is this thing here, which is a combination of a diesel or gas engine and an AC generator that's basically turning mechanical energy into electrical energy, yada, yada, yada. So no matter what we say, whether we just call it a generator or a genset, this is what we're talking about. Technical term is engine generator, but we're referring to this. And here's the picture of it in real life. There's also a lot of accessories, a lot of pieces and parts that go with it besides the big unit. There's exhaust systems and controllers and filters and radiators and batteries and chargers and jacket water heaters and things like that, that we're not going to get into a lot, but it emphasizes the point that there's a lot of things, a lot of pieces and parts that go into the testing and commissioning of emergency power systems. More definitions and terms that you'll probably hear us talk about. Emergency power systems, well, these are definitions out of NFPA 110, but if you hear us say EPS, we're really talking about the emergency power supply, which is the generator itself. And if there's paralleling switchgear or distribution system, that's the supply, the stuff that's providing the emergency power. As opposed to the EPSS, the emergency power supply system, which is the generator, the gear, and the transfer switches, the automatic transfer switches, which are responsible for the majority of the distribution of the power. And here's a picture of an automatic transfer switch. If you ever wondered what the inside of an automatic transfer switch looked like, wonder no more. This is what it looks like. Transfer switch literally is the thing that switches between your preferred source, usually the utility, and your emergency source. When you lose utility power, switches over to the emergency source, the generators, so you can continue to provide power to your loads, in case you didn't know what that was. Now, the code does not treat all loads equally, and there's different codes that define these different types of loads differently. This happens to be out of the National Electric Code, NEC 700, 701, 702. Hospital codes refer to these things differently, but the point is that you'll hear us talk about the different priorities of loads later on in the presentation. Emergency system loads, or we might call them life safety loads, these are the most important loads in your facility. So basically essential for human life, usually for egress lighting, fire alarm systems, smoke evac, those types of systems. These are the highest priority loads, and that becomes important when we get into testing and load shedding and things like that. That's why we're talking about it here, as opposed to the next level, which is your legally required loads. Those are other parts of the code that might require you to have certain things on emergency power. That's defined as your legally required systems. Important, but not quite as important as the essential for human life. And then you have your optional standby or other loads, things that you might want to have backed up by your generator system, but maybe aren't specifically required by code to be. These are your least important loads, and maybe they're shed if you have an overload situation on your emergency power system. There's also different requirements for the level of emergency power system. We talk about level 1 and level 2 systems as they're defined by NFPA 110. Level 1 systems, as you might imagine, are the most important systems. They're more critical. Most of your hospitals and critical facilities are going to have level 1 systems. The codes also define how long the generators have to run, how quickly they have to come online. You're probably familiar with generators having to come online within 10 seconds or maybe within 60 seconds of the loss of power. We throw around a lot of terms, it's a level 1, class 10, or class 48 type 10 system. That means level 1 is the most important system. The class is how long it has to run, how many hours of fuel you have to provide, and then how quickly it has to come online. So that's all defined by different parts of the code, and there's terminology that goes with that. So we have a poll question that we wanted to talk about before we advance that slide. This is why we practice. So, spot poll. What do you guys think is the most common reason that generators fail to start when buildings lose power? And there's your choices there. There's no fuel, issues with the battery, start wiring is not connected, or just overall engine maintenance. And you should be able to click on one of those that you think is the most important, and the results are already up. Let's see, battery issues seems to be the winner. Engine maintenance, close second. No fuel. Start wiring's not connected is actually, I've had that problem where in a facility where the generator wouldn't start because if somebody forgot to connect the start wiring. But anyway, we can close that. And you know, as we're done with the definitions, obviously, but we're going to start talking about, you know, design and construction commissioning. Our job is to look at those single points of failure, and we do find that there's a lot of commonality in why generators might fail, or in the case of that question, why they don't start. And 57% of you were right that battery issues are typically the reason that generators don't start. And there's lots of different reasons, but battery issues tend to be the biggest one. And you can see this list that good people at Prime Power have put together are some of the common ones. But there are issues like the fuel tank was empty, which always cracks me up that, you know, we didn't have fuel in the generator. But, you know, most of these are preventable. Battery issues, insufficient cooling, fuel leaks, oil leaks, control problems, and fuel issues. Those are usually maintenance and operation issues. But as we start the design phase of the commissioning process, we are always looking for these potential single points of failure that, if they can be prevented, that's what we want to do, because there usually is, no matter how much redundancy, no matter how many, you know, N+1 or N+2, you know, levels of redundancy you have, there's almost always a single point of failure that's lurking there, just waiting to rear its ugly head. And if you do this long enough, you tend to be able to start to anticipate, as you're reviewing the design or getting to construction, what some of those common common issues, especially in the design phase, that you're gonna find. And there's a list of them there. I could almost write a design issues log for before even opening a set of drawings usually, but usually have to do with, you know, working clearances and redundancy issues and grounding issues. Surprisingly, environmental characteristics of the rooms is an issue that doesn't get enough attention. Ventilation and lighting and things like that they're very important, don't get attention. But the biggest one, the most common thing that we see, has to do with sequence of operations, or the lack thereof. Go ahead, Jesse, next one. You know, our mechanical brethren are very used to seeing and getting detailed sequences of operations, you know, for how their systems are worked. But we rarely see, or at least I rarely see, a well thought out or well documented electrical emergency power system sequence of operations in the construction documents that lists, you know, how the system is supposed to operate, that shows that it's been really well thought through and documented, what's supposed to happen when we lose power, what the generators are supposed to do, details on the transfer switches and time delay settings and load shed sequences, and what happens then when power is restored and goes back the other way. And it's really not that hard. It really is just a set of instructions, a set of written paragraphs that usually start with, upon loss of power, following things are supposed to happen, which is how quickly are the generators supposed to start? When are they supposed to come online? You know, at what voltage do they drop out at, or just, you know, and then they come back online? And if there's load shedding, how does that work? And it's really not, like I said, not hard, but we rarely see it. And when I show up on site, sometimes, if it hasn't been documented, they ask me how it's supposed to go, and that's of course the engineer record's responsibility to do. So it's very important, and it's something we're going to talk more about as we go through, Jesse, and as Jesse starts talking about construction phase.
Mark, in your experience, the sequences of operation that either are provided or lacking, have you seen the onus being switched from the engineer of record to the manufacturer? The engineer of record saying, you know, sequence to be provided by a manufacturer, or leaving default settings?
Well, I haven't seen much of the engineer of record saying that, but that's what ends up happening, right? And with the lack of any other information, the manufacturer, either the vendor or the installer, sets it up the way they think it should be, or settings are just left on their defaults. And I can tell, when you get there, you can tell that they're still on their defaults, because you get to know what those default settings are. So you can look real quickly and say, oh, nobody set this up.
All right. So Mark's taken us through design phase into construction. And we're talking about construction phase, emergency power system commissioning, and commissioning, as those providers are aware, we're not always brought in design phase. Sometimes we're injected, 2 weeks before the keys are turned over to a building, and just, we're doing our best. The intent, and certainly the guideline, emphasizes early involvement, and that early involvement, in what Mark has elaborated, are these definitions and the importance of the sequence. And what do we do with this information? The sequence may be, this emergency power sequence may be something that is a paragraph. It may be several pages in a spec. It may be a design review comment, a response from the engineer of record saying manufacturer to provide further information. The goal, this value add from design into construction, is to document not only design intent, but before that, what is the owner, what are their expectations? We want to develop a commissioning plan, a means for functional testing a system that would be how the owner would operate. And this logic, this philosophy, is reiterated throughout ACG and really the commissioning approach. And we're talking about emergency power systems today, but know that this approach can be applied to others. The new guideline that's going to come out has some tools and some outline of parameters for leading to greater success. That same thing can be applied to other systems, but unfortunately, electrical folks are just getting involved now. So now we're getting these nice new ACG guidelines. So maybe we'll slowly evolve to other systems. But what I want to capture here is we're in the construction phase. We theoretically know design intent. How do we implement a successful commissioning approach for an emergency power system? 12 different providers, 12 different tests. Is one any better than the other? The implementation of the test or the commissioning approach should be a focus, and really the purpose of this point of the presentation is to highlight you can have the best test, but if you show up at the end of the project 2 weeks before turnover and find 4 weeks worth of issues, who are you really benefiting in that case? So in this approach, we have to account for project-specific design as well as project-specific construction schedule. So to do that, we're not pushing the schedule. Commissioning providers aren't. It's the installer, and it's this team approach that we're going to emphasize in this presentation, and I feel ACG emphasizes as well. Go to that kickoff meeting, make clear the expectations for the installer, what the owner's goals are, their intent, and then just lay out the plan is to commission emergency power components as installation progresses. Make sure that the installer knows that you want to look at that, you want to be there to observe the load bank. You expect that to take this much time, and put that in the schedule. If there's transfer switches, it makes sense that you would do that shortly after. If there's multiple gens in paralleling gear, and it makes sense to the next milestone would be commissioning of paralleling gear. We're testing components, so when we show up at that at the end of the project and we're doing a more complicated test, not we, but the facility operations, the owner, the installer, the team have more confidence in the system that we're going to show up at the end of the project to test. We will have hopefully seen the majority of it work, but now we're just vetting that the system operates as a whole. And it's not what Jesse or Mark or you want to see. It's these tests, the commissioning approach stands on design intent. It stands on construction standards. Anybody that's familiar with government work, interesting set of specs, fairly stringent in detail. It doesn't make it that doesn't make it better for them, for that client. But if I took an excerpt from a government spec, a 24-hour engine runtime requirement, and tried to apply it to, say, a hospital in Florida. Actually, they probably would like that in Florida. Let's just say a hospital in the Midwest. The installer is going to have two responses to doing something that's outside of specs. They're going to tell you to go fly a kite, or they're going to say, "Oh yeah, I would love to write that change order." So these are things that we need to keep in mind as being part of the team. The owner or their advocates are part of the team. It is really being mindful of schedule and construction cost. I've not met a client that wasn't interested in those two things. They likely have some other interests, but that's a good baseline to start with. So this guideline that Mark and I wrote, one of the things we're excited about is the inclusion of some outline for defining what ready is. Again, it can be applied to anything, but we're here talking about emergency power. It's a passion of Mark's and mine. And what does it mean to be ready to commission an emergency power system? The components of it, the system itself. I would love to be able to ask the audience with a show of hands. Maybe this would have been a good poll question. How many people have showed up on site and, despite months of planning, were told, "Oh, we didn't know that's what you meant by ready." So something that I've recently only shared with Mark, this thought outside my head is, every time, theoretically, it happens less and less as our careers progress. Knock on wood, I'm done with, "I didn't know that's what you meant." But we always bolster our approach with lessons learned. So, this, more experienced commissioning provider will know to ask certain things, likely from some past traumatic experience. Maybe an upset client would cause that, but who's on first always popped up in my head whenever one of these situations arose. The point here is the client is the one that feels the brunt of any lack of coordination. It's not the installer's fault. It's no less the commissioning provider's fault. And to find fault, I don't know if that's beneficial to the client. All we have to be aware of is minimizing impact to schedule and budget. This is an outline of some of the ready to commission components that are going to be in the next ACG guideline. We're not going to go into too much detail, but here's an example of one of the, you can say a checklist. It's not complete, but it is a start. I'm going to go back to the previous slide. You show up on site, months of planning to do a load bank test, and this is what you see. The installer who's installing the generator was paid, and their contract is to install X. The commissioning provider shows up, and they're interested in X integrated with X, Y, and Z. So is it the installer's fault that we didn't communicate the interoperability between X and Z, or X and Y? In this particular case, the engine on that generator was ready to load bank. But what the installer wasn't aware of was an NFPA 110 requirement. not Jesse's, not Mark's requirement, an industry standard that the enclosure of the generator is part of the gen set. So in this case, if we're going to run a generator, they're probably not going to fail from a high temp. But is that a realistic scenario for the owner in August, in the middle of, let's say, Arizona? No, they're going to get some artificial cooling from here. We're looking for, when we were coordinating this, to theoretically, I would have asked the question, oh, by the way, all your walls up around the generator. But these checklists that are going to be in the guideline are intended to be some of these lessons learned. You don't need to show up on site and have to look at panels and lighting controls to stay busy because the load bank wasn't happening as you thought. And this is really intended to get us all on the same page with a higher expectation to lead to client success. And that's really what we all want. We're not going to read this to you. It's going to be in the next guideline, and we're excited about it being released. So Mark took us through design. We've taken that design information and owner expectations and incorporated it into the commissioning plan. And then we have met with the installer and implemented an approach. We're going to commission this here, and this here. And at the end of it all, after we've vetted the components, we're going to test the emergency power system. And this is where the sequence comes into play. The sequence should be unique based on design and operation. How do we demonstrate? In our opinion, my opinion, this may be the most important thing we ever do. These final emergency power system tests. How do we demonstrate some of these features? If left to the manufacturer and the installer, and even the engineer of record, most 3.5 fuel quality spec sections do not cover a demonstration that addresses all the programmable features. In effect, the system is never demonstrated. Certainly the components are, and certainly during manufacturer startup, the manufacturer does a good job of vetting what they're intending to do. But the system operating, the generator, the ATSs, the paralleling gear, integrated with a simulated load, demonstrating the sequence, as Mark explained it, is not something typically that would be performed unless directed so. So again, in design phase, this would be a great comment. We're reviewing the spec. Mr. and Mrs. Engineer of Record, how do you intend for us or the installer to demonstrate this feature of this system? It'd be a great design comment. If we show up at the end of the project and say, all right, we need you to bring load bank equal to the rated capacity of this emergency paralleling gear, we're probably, again, going to get 2 responses. And we want to, again, be productive. So having these questions about coordination should happen early. There's means and methods for demonstrating these more complicated features through proper coordination without the client realizing an additional cost. And this is more of the practical approach. I'm just going to talk about this a couple more minutes. If there's time at the end, we can go to more detail. Let's just theoretically, a couple gens, some transfer switches, paralleling gear. One of the ways to do this is to bring out load bank rated to the paralleling gear. Where do we connect that load bank? Are there disconnect up front? Can we pull off the back and connect there? If we can't do that, can we derate the system? Again, not as the owner would operate it, but it's better to do something than nothing. Or a third approach could be a signal generator. Not every manufacturer has a watch transducer, but again, this is Mark warned me about getting into too much detail here. But all this to say that there are methods to demonstrate a complete system, and the pushback from the team that we can't do that without an added cost. I hesitate to say that that can be alleviated with proper coordinating, but that's what we're trying to achieve here. A thought out approach to achieving the goals. This slide is just to show a more complicated system, but the approach isn't relegated to complicated systems. Demonstrating a complicated emergency power sequence is just as important for a school with one emergency generator and a couple transfer switches. What is design intent? Ask the question early, document it. If design intent is to leave default settings, document that design intent. Don't show up on site and just have that conversation with the manufacturer who says, oh, I've not been provided any information. So let's ask the questions early. What do you need to complete your job? How is this supposed to operate? And Mark, I'm going to hand it off to you for the next slide.
So I love that Jesse's slide earlier that showed the generator room without the part of the wall missing with the louver not installed yet, because I had a job, probably had more than one, but I had a job like that not all that long ago, and it honestly never occurred to me to put on the checklist, before we're ready for functional testing, is the wall installed, is the louver installed, and yeah, so that's a real thing, and is really the reason I put this slide together, because there are, when I ran into that and I said, hey, the louver is still not installed here, you got a big hole in your wall, the electrical contractor and the generator installer, they all said, well, that's not my job, that's not part of my responsibility. And I hear that so much when we're doing emergency power testing, because there are so many different pieces and parts and players that are involved, and we're like the conductor, with trying to get all these different players. There's the general contractor and electrical contractor and the generator provider and the switchgear and the transfer switch vendors, and then you've got the HVAC subs, and the fuel system is usually the plumbing contractor, and that's a different vendor. It's so many people that are all have to be involved throughout the process just to commission the emergency power system through the construction, and certainly in the acceptance testing phase. And so that's one of our biggest challenges, is getting all these people, singing to the same sheet of music, if you will. But what I really want to talk about now that, Jesse's talked about, through the construction and the acceptance testing phase, is what we call integrated systems testing. Because now that we've tested all the individual pieces and parts of the emergency power system, and other people have probably tested the HVAC systems and other pieces and parts, it's time to test to make sure everything works together in all different modes. Just because things worked on utility power doesn't necessarily mean they're all going to work the same way when we're on emergency power, or after we've switched between branches of power, or after we've switched back from emergency power back to utility power, because things just don't always work that same way. So what we want to do is we're going to test the HVAC system, the chillers on emergency power, and make sure that they still work after the transfer, and that the BAS system hasn't lost its mind after it's switched between normal and emergency and back again. Same with the fire alarm system, and we're going to run the building on emergency power, test the fire alarm system, and make sure it can still shut down the air handlers and close the dampers and reopen them. And elevator recall is always a challenge for some reason, to make sure that when we switch to emergency power, that the elevator recall works, and when we switch back. And same with other pretty important systems, emergency communication systems, and UPS systems, and security and access control. It's very important to make sure that those things work in all modes of operation. And one of the funnest ways, switch sides, is to do this is what we call a black site test. And that's just a simulated power loss test where you turn off the power and see what happens. And that's an oversimplification. It's a a test that requires quite a bit of planning and coordination and cooperation and arm twisting and begging and pleading and whatever, because you need a lot of different people to be in a lot of different parts of the building. Typically, something we can only do, or it's impossible in new construction. Jesse's going to talk a little bit about existing buildings, but we want to shut down all the power and we simulate the power loss, watch the generator start, watch the transfer switches transfer, make sure that works. And then basically, well, the way I like to do it is turn off everything else except the life safety, except that emergency power, emergency branch, that most critical branch, most important branch, and then walk the building and make sure that things are on that life safety branch are actually working, that the egress lighting is working, that the fire alarm is working, that the fuel pumps for the generator are actually connected to that branch of power, that they're working properly. And then so on, and then add on the branches of power from most critical to least critical, walking the building each time to make sure what's connected to what's supposed to be connected to those systems actually is, and that they're operating correctly. When we get to the equipment branch where the HVAC equipment is connected, and that's where we do a lot of that work, make sure, as I said, air handlers are working, chillers are working, the BAS system is still working, because a lot of times we have problems with that. Elevator recall. And obviously that takes a lot of people. That's not just, Mark or Jesse just walking through the building, because that'll take a long time. A lot of people coordinating that effort. And then we want to retransfer that back to utility source power and do another quick walkthrough and make sure that everything is still working again once we've transferred back to normal power, and make sure that things are operating. As I've said, it's absolutely essential that we test to make sure that everything is operating and working properly in all modes of operation. Otherwise, we're really not doing our job.
Mark, in a healthcare application, do you think it's significant to make a difference or make a distinction between this test that we're referring to, an IST black site test, and what an AHJ would want to see?
Oh yeah, that's a great question. Because typically, at least in my experience, most of the AHJs they're mostly just interested in that life safety, branch. They want to make sure the egress lighting is working and maybe the fire alarm. Here in Florida, for healthcare facilities, anyway, our AHJs do a lot closer to what I'm describing. But typically AHJs aren't interested in much more than the egress lighting, in my experience.
Jen, I think we're going to have a poll question here before we move on to the next slide. How would you characterize your company's experience with commissioning an emergency power system in an existing facility? Not common, growing, confident in own ability. I think maybe just give it a couple moments before we go on to the next slide.
Oh wow,
pretty healthy split.
Yeah.
That's good.
Interesting.
Yeah, if anything, we get an idea of how many folks are paying attention. So again, we're back to the guideline, ACG's upcoming guideline, the new one that Mark and I participated with. That there is going to be content in there about existing facilities, and there should be. And when we say existing facilities, it's not limited to just run in, no new work, but we're also have in mind, and maybe even more so in mind, the opportunities for existing facilities that have new emergency power work. And this is typically the clients that have been increasing of late, at least from my perspective. Not everybody, it's not always appropriate to do a green new build. It's economical, particularly I think HCA has been doing this the last at least 5 years, purchasing existing facilities and expanding existing. So it has to do with the economy of the construction world, and there's really no telling what's going to happen in the upcoming years. But this was important enough to include in the next guideline, at least some not direction, but at least some points to talk about, to provide confidence for that other third of the group that wasn't quite sure. And what we want to capture here is this approach in an existing facility is it may not work. There are certainly clients or certainly instances where demonstrating the system is not, you can't do it. What the guideline provides for and what we want to encourage is having the discussion to determine that that's the case. Can we alleviate any concerns that would allow us to do some tests, again, rather than nothing? My previous mentor told me it's yesterday was the best time to test an emergency power system. Today is the next best, and tomorrow is too late. Anecdotally, I think we have time. A squirrel story. We had a client install a couple new generators on an existing facility, and we sat down with them, tried to address their concerns, and it was a hard pass for a more complete emergency power system test because they didn't want to affect clients or staff. That's reasonable. And they're the client, so we left it at that. 2 years goes by, there's a fault, and there's a failure and a loss. And they come back to us and they want to do the test that we had originally planned. And I'm here to tell you, the test that we ended up doing was substantially diminished from the test we could have done the prior 2 years. And we must have spent a year planning this test. And if you can just imagine a year of meetings where somebody sits down and says, we need to do the squirrel test, and how annoying hearing the squirrel test repeated for over a year could be. I want to spare y'all from that as much as possible. So how do we address concerns? As commissioning providers, we need to be able to put on different hats, sit down in a room. Somebody says we can't do this test. It's often the person that doesn't quite understand, and this isn't to be demeaning. Maybe it's somebody who makes financial decision that's a client. Maybe it's apologize if there's any data IT folks on the call. Y'all seem to run the world, so we certainly want to get data IT folks in on the conversation. Let them know that their UPSs are safe. Them and elevator controllers, they're a special breed. Even the head nurse, sit down. What does this test look like? The concern of, well, we don't want to cut power to the building. Well, what if we can start the generators, transition load, whether it's open or closed transition, and minimize impact or any perceivable difference of priority one loads, and then relegate the test to demonstrating shedding of new and or existing non-priority one devices. Well, what if we're in Phoenix in August and we're talking about shedding equipment load? It doesn't need to be in August. Let's take this mechanical term of a post-season testing applied to electrical. Let's say we come back in January and do this test. Maybe if we have somebody standing in the hallway monitoring temperature, and when it gets a little too hot or a little too cold, we bring those shed loads back on, those equipment branch, condition the space satisfactorily, and we continue with our test. Maybe there's a concern for an event, a medical event, an emergent event, life flight or an ambulance, an unscheduled surgery. What if we can tell the client, the facility operations individual, that we can back out of the test in 6 minutes? We're going to put somebody at your hip at the head nurse's station, and if they say stop the test, we can say we can get out of this test and restore to normal operation in 6 minutes, or whatever it may be for your facility. These are just some anecdotal concerns that clients come up with, and they're all valid, every single one of them. They're valid because it's their concern, and it's our responsibility to do our best to address them. And in the commissioning provider, we're all unique, we're all different based on our experience. In this guideline, what we're excited about is it's not limited to new construction. These are, in my opinion, this is the most important system, most important thing we'll do in commissioning. You know, I know it's important to save energy with HVAC and lighting controls. It seems to be the bulk of the scope. This will be the hill we die on, emergency power systems. And sitting down in a room with all the individuals, all the players, being comfortable with addressing concerns, we hope this guideline provides some guidance for that. You know, this slide, the whole purpose of this slide is to show that it's not binary. It's not emergency power system, normal power. We're talking about demonstrating a system, and that may involve a dual utility fed system with a main auto throwover sequence. It may be a normal power loop distribution. How do we simulate a failure of utility while we're demonstrate the emergency power system while minimizing impact or helping the client understand what is being impacted? What if the concern is we can't shed that load? Well, maybe we take that load out of the test. You know, maybe if we can tell the client this load will see 15 minutes of outage, maybe that'll help them understand what really is being impacted. And I'll always argue an actual outage event during an emergency power test, the generator is already running. We're not shedding, nobody's shedding priority one loads. We're in a better place. So it's really an opportunity to provide confidence, whether it's new or existing or a modified existing. When we walk away, we want that facility operator to know that they've seen this system operate. The manufacturer is not going to do it unless they're told to demonstrate the system, the complete sequence. The installer is not going to do it unless it's in the spec, and I probably see a spec written like that once a year, once every other year. So the onus is on us to try to do our best to coordinate some level of demonstration. And that's truly the task. I could talk about this all day, and I would love to talk about this all day. And as Mark said, we're both particular fans. What I want to convey with this slide is commissioning providers, we document and we plan for all inevitable outcomes best we can. It has the best laid plans still could fail, but it's the intent of the commissioning provider to have some team success, and the emphasis here is team success equals owner success. So we need to define what first of all what those goals are, what the goalposts are, and move towards them. You know, this is apologize for any Marvel fans. You know, they had a great plan. It was like a 5-minute fight sequence, and it didn't happen as they thought, or so we thought, until the second final movie. And with that, I'm gonna. This is technically our last slide, one of our last slides. So, Mark, did you have anything you wanted to add here?
Freaking Star-Lord, always messing things up.
Yeah.
No, just that, I like the slide because, it takes a team to commission any project. And that's what I hope your takeaway is from our presentation.
One thing I did neglect when we started, Mark, somebody that couldn't join us today that helped us with this presentation was Barry Cromwell. Yeah, he was instrumental in helping us get straight with definitions, and the next guideline. I think it's a I'll say work of art. I don't want to be, it's self-deprecating, but Barry was instrumental in helping us get to where we are today, and he can be on the call with us now. So with that said, and Mark, unless you have anything, I do believe we do have one more poll question. Is that right, Jen? There we go. I'm going to read it. I'll preface this by saying it has nothing to do with what we just talked about. I'm just curious. So from your understanding of NETA, would a NETA certified technician typically be responsible for performing electrical commissioning services? And with that, I'm going to move on to the next slide, Sam.
Okay, thanks, Jesse. All right, Mark and Jesse, thank you so much. We have a decent amount of questions lined up. If you're interested in asking a question, you can use that Q&A button and I will do my best to get to them. So start off here. I'm going to combine these first two questions together because I think that makes sense. First is, what is the most important part of the sequence of operation, and whose responsibility really is it to provide the sequence of operations?
The answer to the first part is yes. It's all important. The most important part of the sequence is to have it. And it's obviously the engineer of record is responsible for providing the sequence of operations.
Thank you. Next question. Do we have to commission all of the egress lightings, fire alarm systems, et cetera, or just a percentage of them? And if it's a percentage, then what number is that?
I would ask what's in your scope. That is a good question. And the answer to that is what's in your scope. What does the owner want?
That's right.
Okay, thank you. Next question. Does the generator need to be a certain size before the load bank testing is required?
I don't think so.
No. NFPA 110 defines emergency gen sets by the load they serve, not, as far as I'm aware. If anybody knows different, please comment, but I'm not aware of a capacity or rating condition.
Next question. Is it normal operation for the commissioning professional to confirm voltages at electrical panels while building is on EPSS?
I would say, back to what Jesse said about, depends on what the scope of the commissioning is and what the engineer or what the owner wants. But I would say if the emergency power and the distribution is part of the scope, then yeah, probably. Maybe not at each panel, but certainly on the the emergency distribution board or paralleling switchgear.
If my scope was to commission emergency power system, I would not go check voltage at panel boards unless that was a scope item.
Unless it was in your scope, yeah.
Yeah, that takes effort. And normal panel board, if the scope just reads emergency power, we're checking voltage at normal panels. I don't know if there would be anything there, but if it's checking voltage at any panels, that would be a scope clarification. We have done it. I wouldn't do by default. And the answer is I would love to do that. We just would need to be compensated for your time. But because that takes time, and that's something outside of, again, we didn't really touch on defining scope or contracts, but the next guideline does. I'm fairly confident there's a section about contracts and scope, and that is addressed.
I'm definitely going to check it at the paralleling gear and the transfer switches, especially if that metering is already built into the gear. But yeah, not down to the panel board level unless that was specifically requested in the scope.
Okay, thanks both. Next question. Does the commissioning technician need to be NETA certified to write or execute the installation checklists and functional tests? And then also, what was your take on the last poll result?
Did Jesse write that question? Did you
Yeah,
think that
I would,
while you
I'd
were
love to answer that. The answer is no. And I don't mean to, let me say it this way, it's no to my understanding. And it depends on the clients. The last poll question, not to detract from the topic that we're discussing, but they are separate topics. So to answer this question, no, you don't need to be NETA certified to perform commissioning. And I do think that this is a bigger topic, maybe warranting of a further discussion, but I don't want to take the time now to do so.
Okay. Unless any more pop up, this might be the final question we have. If you had one site visit to verify full functional operation of the EPSS, would you choose to integrate your site visit with the manufacturer startup and load bank testing, or would you wait until the load bank test and startup reports have been submitted? And if you choose to wait until the project is complete, do you require the manufacturer technicians to be on site when the blackout test is demonstrated?
You want that one, Mark?
Well, I'll tell you what I would say. First of all, would never just have one site visit for your functional testing, probably. But if I was limited to just one test, I wouldn't do it with the load bank, because you could, as much as I like being there for the load bank test, I would just have them do that and get that report and review it, and then I would go after that when everything was done and ready and do as close to a black site test as I could. And yes, we would need all the vendors and manufacturers and all the parties there, be present and help with the testing and make whatever adjustments we needed.
Okay. There was one other that popped in a hospital facility. Why would you test voltages at the panel?
Good question. I've seen voltage testing on receptacles, like end of line type of testing, and really questions like that aren't uncommon. When I say like that, like maybe some people are scratching their head. Why would you even do that? These questions are asked because there's a facility operator who's been doing this 30 years and got burned on something and doesn't want to get burned on the next rebuild. So they want that in the scope. So when they say, are you checking voltages? They probably have some lines with noise on it, and there's some equipment and they have issues with motors, VFDs. So there's the big picture, the takeaway is that there's validity in the concerns. The concerns should be addressed, ideally in design phase when the contract's being written. When somebody says, we want you to commission an emergency power system, clear as day. And that's what this guideline, the next guideline lays out what expectations are based on construction standards. What to look for in design, how to answer that question, because ultimately it's what the owner wants, right? It's not what ACG wants. If the owner is defining panel voltages as part of the EP, so be it. You put that in your scope and you provide that service if you're competent to do so. But you need to identify that early, so you avoid showing up in the field and then somebody asking, well, why aren't you doing this? It's they're responsible. You didn't ask me to. It doesn't go very far.
A couple more questions did pop in, so while I have you two here, I'm going to fire away. How does the CXA simulate frequency and voltage variations from utility power to energize or transfer power to the generator ATS?
So if I understand the question, how do we simulate conditions that would initiate a load shed or some other type of programmable function of a sequence of operation? I don't know if that question asker can respond to that, but if that's the question, so we laid out, briefly using load bank, using some load and derating the system, not caring about the load you have connected, but injecting a signal, a 4 to 20 milliamp signal. That only works with some paralleling gear, but again, better to do something than nothing. But how we simulate these conditions, there's multiple ways. Using a signal generator, we're not really doing that, right? Because we're bypassing the CTs and the PTs, and the current and power transformers. We're bypassing the meters on the bus. And so we're not really causing the frequency to get out of line. We're just tricking the controls into reacting to a scenario we're creating. And that is something not done by the manufacturer. And that's just like bare minimum. To us, that should be the baseline for 3.5 field quality in the spec. Demonstrate all the features. How do we actually? And I believe the question is, how do we actually demonstrate these? Bring out enough load bank. And if you hesitate and you're like, well, I've got 3 2 megawatt gens parallel. That's 6 megawatts. Cool. You can do that. It's like because we're not comfortable or afraid of it. Maybe that provider shouldn't be doing that test. But I can tell you it's possible, and it is recommended to do more than nothing. So actually using load bank would incorporate a load on the bus, and the CTs and PTs would engage. And Mark, correct me if I'm wrong. Let's say we bump up the load to 120%, of the bus. Does that just create an over voltage, or is that an under frequency?
I don't know if it would create a frequency problem. It would definitely impact the voltage. That's what I was going to say. Is that would do your voltage test. I don't know if it would do the frequency. I don't think it would affect the frequency.
I don't think so either. I believe that one's difficult to demonstrate with most systems, but what we're trying to get at, that is one means of load shed. There are other indicators for load shed or activating parts of the sequence of operation. And that's what we're trying to do, something than nothing. So to that question, to answer that question, I don't know. If somebody knows how to demonstrate an under frequency, I think there's a chat in the Q&A, so holler at us.
Yeah.
All right. Final question. Are you guys seeing the EPSS being integrated into smart or microgrids? And if so, can you share your experience on the SOC?
I haven't seen it yet, but that is definitely coming.
Not common, and I'll say I've in the few instances where I've seen emergency power system integrate with a grid, there was a unique level of control that utility had with hospital equipment, and I've never seen it anywhere else. And that was simply the agreement that this healthcare facility had with the grid. Yes, it is out there, and what I'm trying to convey is that it should look unique, and it may look weird to somebody seeing it for the first time. In this particular instance, facility had the ability to shut down, or utility had the ability to disconnect emergency generators in a hospital. All that to prevent backfeeding the utility with emergency load if somebody was working on it. So it was almost like a utility disconnect into the hospital, and it was an unusual circumstance.
And I've had that. We've done that, and Jesse's right, because the emergency power for the facility has to take priority. I think the question, if I understood it right, was more about microgrids and using microgrids as part of the overall emergency power for a facility, being the EPSS being part of the overall microgrid, which I think is coming, and you're going to see a lot more renewable energy sources and alternate energy sources that are able to be incorporated into a facility's emergency power supply. And generators just being one part of it, maybe with fuel cells and solar and whatever else we can think of. And the codes are moving in that direction to allow that.
Well, Mark and Jesse, thank you so much for your time and coming on CxEnergy Virtual.
Our pleasure.
All right. As we close out on the final day of CxEnergy Virtual, I want to thank all the presenters from this entire past month who came together, even in a virtual setting, to share their projects and experiences with the building community. If you happen to miss any of them and you are registered for the full bundle, please search your inbox for emails with access to the recordings that are sent a few days after the live event. And then in addition to the live presentations that we've seen this past month, there are also 8 more pre-recorded webinars yet to be released. So please keep an eye out in your email. We will be sending out access to those very soon. And for those of you who aren't familiar with us, CxEnergy is presented yearly by the ACG Commissioning Group, the Energy Management Association, and the Associated Air Balance Council. Together, these organizations, which we like to refer to as the authorities in building performance, represent over 600 member companies and 2,500 certified professionals in the testing, adjusting, balancing, commissioning, and energy management industries. So as you can see, we plan to be in Orlando next year, so please save the date and we hope to see you there. And although CxEnergy 2021 has come to an end, the authorities in building performance still have a year full of webinars, certification seminars, and training sessions. Be sure to subscribe to our mailings at abc.com or commissioning.org to receive updates and invites to future educational offerings. Or you can follow us on LinkedIn or Twitter to stay tuned in on our events. And then in fact, the Energy Management Association is hosting an EMP seminar next week for candidates of the ANSI accredited and Department of Energy recognized energy manager certifications. Instructors will be explaining EMA's commissioning-based approach to energy management that maximizes energy savings and optimizes building performance. So if you're interested in that, please check out energymgmt.org to learn more. And Jen, if you could pull up the next slide for me. And before we end, I just want to thank our exhibitors who participated in our first ever technology showcase. We have Meritech Data Solutions, Purple Swift, BASG, CxAlloy, Vitality, EAB Training, J2 Innovations, Facility Grid, RetroTech, Blue Rhythm Commissioning Software, TossyBox, and Sky Foundry. Thank you for hopping on and giving our attendees a chance to stay up to date with the latest building technology and services. And then finally, Jen, if you can click the next slide, please. I just want to take a moment to recognize all of our webinar sponsors who helped support CxEnergy this year. TLC Engineering Solutions, as you saw today, Phantom Factory, CxAlloy, Sky Foundry, Evergreen Telemetry, Auto, SSRCx, as you also saw today, TSI, Copper Tree Analytics, Building Fit, Facility Grid, Clockworks, SenseWare, and Drone Deploy. Again, we look forward to your continued support and thank you for participating. So that's it for me. Stay safe, stay healthy, and we hope to see you all again very soon. Thank you all.
Good job, Sam.